Hello, everyone. Welcome to today's live podcast recording series with Andreas Kretz and me, Marinova, your host. And today we'll be talking about data engineering. Hi, Andreas. How are you doing today?
Hi, Mary. Yeah, very well. Thanks.
Where are you joining from?
I'm joining from Germany, so a bit over the
Nice.
pond for most of the people.
It must be cold and late right now.
Let's not talk about the weather. It's depressing here.
All right, all right. And what about you guys? I know some we're recording it live, so some of you are joining. And say hi in the chat because this will be recorded, and get ready for the Q&A session towards the end where we get to ask Andreas questions about career in data engineering, Gen AI, and everything else. But yeah, let's get started, Andreas. Why don't
Yeah,
you tell us a little bit about yourself? I know you've been in this field for like, if I'm not mistaken, more than 7 years.
a long time. Yeah, it's.
Okay.
I started with this when it wasn't called data engineering, so
Oh
um,
wow.
yeah,
What was it called?
it's been a while. Well, back in the day, people were saying it's big data, the big data field. That was when the big data hype was here, but uh, it's it's been a while.
Mm.
Yeah, I see in the chat. See a few people here. Hi, everybody. My name is Andreas. Like Mary said, I'm from Germany. I have two kids and a wife, and I'm having here my studio where I record courses and about data engineering and coach people about data engineering. And I've been doing this for a while, but I started back in the day as an apprentice in mechatronics, where so mechanical engineering, electrical engineering, and then I went into the whole computer science thing and got my university degree at 30 years old. So I was a bit late on this, but how I started with all of this is actually in my thesis I was creating a concept for a condition monitoring system where you have out in the field machines and these machines sending the data in and you're looking at the data that is currently basically happening. Now this evolved into a predictive analytics topic where you're predicting is that machine going to go wrong at some time, right? And with that, back in the day, with that came that problem where while I studied, I learned SQL, I learned relational databases, I learned relational database modeling, and all that kind of, let's say, traditional stuff. But suddenly there was so much data there where now the processing doesn't work anymore and there is too much data to be ingested and to be stored. And through that I actually got into that whole thing. And as I said, back in the day it was called big data. We were working on Hadoop and with MapReduce, and yeah, this evolved. The projects evolved. I got into a team lead role back in my old employer at Bosch, and at some point I started with coaching, started with a bit teaching data engineering, and naturally that then was the next step. I also did a lot of YouTube. I'm still doing a lot of YouTube, and then I started this since 2021. Mid 2021, I'm doing this full time teaching with my academy. Over 2,000 students I taught data engineering so far, and yeah.
Wow. Wow. No, that's, I think there's a lot to unpack. I mean, if you came from Hadoop and big data days, I mean, must have been so much change. And every year, even these days about Gen AI, I'm excited to talk about everything. Um, Great. So why don't we start with just the basics then? What does data engineering mean in 2025? I know you said you've been coaching a lot. Do you think that definition like has changed over the years?
The definition has changed a bit in terms of the tools that we use.
Hmm.
Like you said, we were back in the day. It was Hadoop, it was maybe Java, and so on. Now it's a lot of Python. It's a lot of cloud right? The cloud really gets strong, but the let's say the essence is still there. That at some point, somewhere there's a source, and on the other side sits somebody who wants to do something with that data. That might be a data analyst, that might be a data scientist, that might be a user that is sitting on the user interface and trying to look at some data. And our role as engineers is basically everything in the middle, right? Transforming the data, bringing the data from the source to the destination, making it available to these people. And that's that for me. That's still that definition is still there. It hasn't changed a lot. It's just the hype around a lot of tools that has also changed.
I'm curious actually, because there are so many, as you said, there are so many tools and use cases. Is there maybe a bigger subcategories of data engineering within the field? Let's say data engineering for enterprise, or data engineering that only work with transactional data for software engineers, or how does it divide in the industry?
So you're already getting to the right points. A lot of you have usually these two types of applications. You have a transactional application where there's something happening like a credit card transaction, and at the end is another platform, or maybe it's an e-commerce environment where there's a sale happening, and the user then wants to see the sale directly in the user interface, right? That's one. The other is analytics. Everything with analytics, with business intelligence, with improving the internal system, trying to make more revenue with the data through marketing. And so these two areas are always there. Depending on the company where you are, it might be more towards transactional stuff or streaming, and more the others more towards analytics. Always depends on the actual job. So these are usually the areas. Of course, then there are also the other specialities, like more towards architecture, that engineers are more towards platform architecture. Other people are working a lot with machine learning, so they are getting into the role of machine learning engineers. But the main thing is still the same: creating data pipelines, and then managing those data pipelines and looking after that nothing breaks. And if something breaks, we fix it.
Got it. No, this is a great textbook definition of data engineering as well. Whenever I first learned about data engineering, I understood immediately that there's transactional and analytical. But coming from data science perspective and machine learning, do you think that analytical is also part of machine learning, data engineering?
Well, yes, there is, and machine learning is a part of the analytical process, right, or of the analytical side. But there is, like, not every analytical thing is a machine learning thing. You can do a lot of stuff with simple analytics, and so that's how I usually look at this. Is this machine learning, or is this, let's say, standard analytics, where a data analyst sits there and analyzes some data, not a data scientist?
Got it. And Andreas, I know you're so the actually how I found out about you was through one of our community members last year. His name is David. I think I mentioned it to you. And he was like, you should have Andreas over because he helped me so much with just transitioning and landing my first job in data engineering. Because back then he was just getting the internship, I think. He was working with sensor data. And I remember on one of our accountability calls, he was overwhelmed with like so many tools, so many projects. I remember specifically he was asking about Azure infrastructure, and that's when I learned, oh, interesting. Europe is big on Azure, and also for beginners. What do you think people need to start, or people who are trying to get their first or maybe second data engineering roles in the industry? What are the things they need to learn? Is it data modeling, or is it specific tools or cloud infrastructure?
Depends on, do you mean for if they start from zero, or if they already have a job and they want to transition into it? Right? Because there's a difference in that.
Interesting. What's the difference, you think, there?
Well, let's say you come out of university, you have your data or computer science degree, And then you need a bit of different skills than then your path is a bit different than if you're starting as an analyst or if you're starting as a software developer. For somebody, generally, I would say the basis is what you need to understand Python. You don't need to be a master of Python, but you need to understand the basics, and you need to learn how to process data, how to work with data through Python. You need to understand relational data modeling and SQL. I always called it SQL.
I was like, what is that?
I'm one of the guys it's not SQL, it's an abbreviation. It's SQL.
Okay, we'll talk about that later. But
Structured
that
query
was
language, right?
guys, whoever is in the chat, tell us how you pronounce sequel.
Yeah. Put a 1 in the chat if you're with SQL. If you're on my
Sequel. This
side.
is sequel for
2
okay.
for SQL. What was I saying? So yeah, so these two are the basis, I would say, right? Because then you can work with databases, you know how to transform data, and then you can go towards working on the cloud. You can work towards data modeling, maybe dimensional data modeling, right? If all the jobs that you're looking at, you are going and you're seeing these are analytics jobs, right? That are basically helping data analysts work with it. Then it might be interesting for you to also look into dimensional modeling, and then add a data warehousing, something like Snowflake and processing with DBT. I see ones in the chat. I
I love that. Emily, Malik, you guys, Justin, thank you for supporting us. Great. Yeah. And
So
by
not
the
long.
way, if you guys have any questions during the presentation, because Andreas has prepared some slides, feel free to ask follow-up questions in real time. But yeah,
Yeah, put them in the chat. We're going to get to them. It's not a slide war here. I just have a few, and that's
I
it
mean,
then.
you wrote the entire book. I don't know if you guys will share us with everyone if you guys seen Andreas's book, and it's on GitHub, and there's so many resources that you put out there for free, which is amazing. Is that how you managed to teach 2,000 people?
Well, these 2,000 are just through my academy. I don't know how many I taught
Oh
over the
wow,
cookbook and YouTube and so on.
wow,
So tens of thousands. The
great.
cookbook that actually started as a fun project. Like how can I create a resource for people to get into data engineering, and that grew throughout the time. And unfortunately, I don't have enough time to like continue because there is so much stuff that I'm working on, but I don't have the resources to every day put stuff in there. But I'm updating it from time to time, and yeah, it has grown, and you can find resources to projects that people did, to YouTube videos, to courses, to books that are interesting, all kinds of stuff.
Yeah, you guys, I will share all the resources after the event for whoever has registered. But let's get back to data
Yeah.
engineering career. I had interesting question pop up. Actually, I asked ChatGPT yesterday. I gave you your profile. I was like, what are some of the interesting questions that we could ask that nobody asks usually? And I think it was still not as creative as I thought, but one of them I liked, which was what is you think the most misunderstood concept in data engineering or misunderstood thing by beginners, especially that they need probably, but in fact, at the job, they might not need?
Yeah. So one of the most not how's it ununderstood, no, what's the
Misunderstood?
no, misunderstood. Now my English is sometimes it's tricking me. The most misunderstood things is that people think once we develop something, that is it. And I also learned this from working at the job. The leadership people, they make their timelines, and then they think, okay, now we've created, that's it. Now we can go and we can do 100% of the time or invest 100% of the time into new things. but there's this big thing of actually operations that people very often don't have on their radar, and they completely misunderstand. They think okay, we create the pipeline, done. It's done. It's once developed, and because there is a lot of stuff that is changing. Sometimes the source data is changing. Sometimes the destination is changing. So
Hmm. So it's more like
difficult
an
sometimes.
ongoing thing. It's never one set and
Yeah,
done.
yeah,
Got it.
never.
Got it. That makes total sense. And I guess a follow-up question to that would be, what do you think about data modeling when it comes to just setting up that business logic for how we collect data, store data, and everything else? Do you think that is one of the most important skills, or?
It's I would say it like this: the data modeling part is something you do at first. Oh, Mary, are you still okay? You were frozen. It's something you do at first. You will look at the data. You will look at the like, what's my goal? Who wants to work with the data? How do they want to work with the data? And then you most likely create a data model. But it's not that like I sometimes feel people make a bigger thing out of it than it actually is.
Interesting. Why is
It's people, oh, we need to invest hundreds of hours on doing data modeling and so on. It's not that big of a deal.
that?
So, but it's something that is important, that is very early in the phase of development, of creating your platform. If you mess this up, of course, then you're in big trouble. But nowadays, it's not that big.
Hmm. What do you think, like with those tools coming up with the DBT and everything, is data engineering gonna change? And how's the current market looking like?
Yeah, I think one thing that is currently changing a lot is that companies invest a lot of resources into creating data observability tools or platform observability, right? So that you understand, okay, what is happening right now? Is the data changing somewhere? Do I have some side effects somewhere? And that you get alerted quickly, because that was always a problem, and the fix for it was never really there. You had to do a lot of self-developed processes that you actually find out early if something goes wrong. So I think that is changing a lot right now. But in terms of Gen AI, some people always ask me, basically in every live stream that I do, Andreas, will AI replace data engineers? No, I don't think so. Maybe maybe parts of it, maybe more in terms of helping us, like doing this kind of preparation for data modeling. Right, we don't have to do everything our own. Uh, it can help us in terms of maybe some preparation or some templates for source codes, right? That you I want to do this, then you have the Gen AI in, and the Gen AI supports you, so make it more efficient. But as I said, the development part is only a small part.
Hmm.
Is there is so much around it, and when you think of, okay, now as an engineer, that source part, where's the data coming from? That data usually doesn't come from nothing, right? Somebody sits on the other end, so you need to understand and you need to communicate with these people. What exactly is it? How do you do this? What are some exceptions that can happen? How's the notification when something changes? Are you going to notify me? And on the other side as well, with the business stakeholders, and like you, it's difficult to
Oh,
automate this through AI, right?
mm, interesting. I think that's what many people miss, especially when trying to get their first job. They think technical skills and portfolio matters the most, but at the job, it turns out it's all about communication skills. But I think that answers your
It's a
question.
big part, yeah.
Yeah, Emily asked over here. I think, yeah, I think that was your answer too. What do you think of low code process and ETL tools like Power Automate? Yeah.
Data Factory, Glue, yeah, all good tools. I like sometimes people think I'm the hard coder. If you looked at my YouTube and heard a lot of the live streams, people think I'm absolutely against this. But I think these type of low code systems are good. Sometimes even no code systems are good. It always depends on what you're doing, what you want to use the tool for, right? And that is one of the big things for an engineer, figuring out what is the right tool for the job, because you don't want to have an overkill solution that actually creates more overhead that you actually need. And
Mm,
if for your job such a solution works, perfect. Perfect.
mm,
It's good. But you need to stay open so that, let's say, the data factory or your Power BI Automate, you're getting to the point where there are features that they're not there. You need to keep yourself so flexible that in your platform you can actually then move to a different tool, a different solution for this.
mm. I think that also answers Justin's question on how can they avoid feeling by the know every tool for a job. So like I know many people get overwhelmed by the so many tools out there, and now we have even more with Gen AI and no code tools. But exactly, that's what I like to say: stick to your domain, stick to the industry, and industry will tell you what tools they use the most. At least that's what I think. What do you think?
Yeah. Yeah. One big indicator is looking through job descriptions. Just looking through what are they requiring, what is it, and if you looked at enough, you will see a trend happening. Like a few tools are always mentioned, and this way you can try to yeah, figure out what do companies need. But I think this is a cool segue into the platform blueprint, because I want to give you a message with that. So let's quickly talk about this. I created this. I don't know how long this is since I created this. 6 years, 7 years. This is just a rough overview. And one thing I want to give you with this is that the important part is that you understand which areas are there in a data platform. And these names are, like, you can change out the names if you don't like them. Basically, I start, when you think of it, and for everybody who's listening to the podcast, think of it on the left, you start with a phase or an area that is called connect. This is where you have APIs or speak with APIs. This is where you have apps like either a Python script that is running that scrapes data from the internet, or where you could also have something like Data Factory there. And this is also on the left side where you would have other databases, for instance, your enterprise data warehouses that you don't manage but somebody else manages, or relational databases that are in the company that you need to integrate. I could also call this the integration phase or stage. And then in the middle, I have 3 stages that are basically, I made it that on the bottom there's a buffer stage. This is where you find usually your message queues, where you find some cache solutions that are traditional, like memcached and so on. And then in the middle you have some processing framework, and on the top you have storage. And data can basically flow through this, right? So it could go from your connect phase, from data integration, straight into the processing framework, where you either have streaming or where you have batch processing, where you might have your error flow that manages those processes, and from there it goes into the storage. Either it's something big data, it's something with or a data lake, or it's a transactional database or a data warehouse. So in the middle is basically processing and storage, and intermediate like message queues. And on the right side, this is where you have your visualization. This is where you have web UIs, you have BI tools, and so on, right? Because at some point it will go into the visualization phase. You need something where you need an app or whatever. So the important thing is you need to understand these phases or these areas, because the tools that are in these areas are very often interchangeable. So if you look at the Azure platform, or when you look at Databricks, and you look at Snowflake and so on, you can see, okay, I have these solutions, or if, let's say, even if it's open source, you have, for instance, DuckDB as a storage solution for like a data warehousing solution, or you have what's another one? Um, that's an open source one. I'm blanking on this right now. Or let's say you have on AWS, you have Redshift. And that's basically where you can see, okay, these are the different platforms and these are the different tools that go in there. Maybe Mary, you can come back so we can chat about this.
Yeah.
You know, you see what I'm trying to do here with this, that you try to figure out, okay, what are the tools that are comparable to these.
Mm.
I
Mm.
have on my website, I have something that people can download with this blueprint, like a tools guide, where they see all these. This is open source. This is vendor. This is AWS, GCP, Azure, and
Oh.
where they can see, okay, what tools are in of these each of these areas.
Oh, where is it? Is it in your cookbook?
No, that is basically when they go. Let me see here. When they go to learndataengineering.com
Mm.
on the website of the academy, you just scroll down and there's a thing where it says download the free skills and tools guide, and
Great.
that's basically where people can download this. But I think that is of course the ways how you build this are all, it's not that linear, because you might have a storage, you have your data lake, and then you have the processing framework, and data basically flows from the storage down to the processing and again up to the storage, right? So the data is always in transition, but the important part is understanding these areas, that although you have there are these 20,000 tools out there, once you understand where to order them into, it's super easy to see, okay, Luigi is the same, can I use this for the same stuff as like Airflow or something, right? So you understand, okay, these are the workflow orchestration, these are the scheduling tools, these are the processing framework, and yeah, you see, okay, I have Kafka as a message queue in the buffer section. On AWS, it's Kinesis. On Azure, it's Event Hub. So it's basically the same. It's literally the same thing, just with different names and on different platforms. But it works the same way. It has the same um, responsibilities.
Hmm. So if somebody, let's say, goes to the data engineering interview and they ask about how they model a certain thing, then they shouldn't bring up tools as much. They should just stick to fundamentals and say, "Hey, this is what I would do for this specific function." Or
I think, uh, like I said, I think the important part is you need to understand it. You need to understand data modeling. You need to maybe practice it. But at some point, you need to get into the doing part. And
Mhm.
then it doesn't really matter which platform you build it on, because it's literally the same thing everywhere. It's just a different platform. The only thing is you need to do a bit of research. What does it make sense, or which platform does it make sense to go into? Like you said in the beginning, here in Europe, a lot of companies use Azure
Mhm.
because they're already in the Microsoft ecosystem, and they have their Microsoft Teams and their data storage on Microsoft, and they have the contracts with them, and then they need to do the whole GDPR shenanigans, and they know, okay, if we just go to Azure, it's Microsoft, we have already contracts with them, we have people connected with them, so let's just do it, right? And
Mhm.
in the US, it's more AWS.
Yeah,
Um,
and
yeah,
GCP for startups over here.
a lot. Yeah, yeah, that's true.
I see. Yeah. Do you guys have any follow-up questions regarding this blueprint that Andreas shared? This is a great example for people who feel like they're overwhelmed, because you can come back to this one and say, hey, do I know these every single part of this equation? And do I know some tools that are popular that I could use probably for the project? How do you advise people on like building their portfolio?
I think it's always important to have both use cases, like a transactional use case and an analytical use case.
Hmm.
Analytical might be used more, but it depends on the industry that you're looking at, that you're interested in, and maybe, well, nowadays a lot of people are working remote. Back in the day, it was like you needed to look which companies near you are there, what jobs do they have, what industry are they in, what tools do they use. Now it's a bit more. We have a bit more freedom.
Hmm.
Yeah, but I think the research part is important. It is very important to do.
Hmm. In the beginning, before you start applying
Yeah,
for jobs, guys, you need to do
yeah,
your research.
yeah, and create a few projects because by the way, we want to remove this from here. I
Sure.
feel like this is in my way. I don't see
Yeah, no worries.
you. What was I saying now?
Research is
Um,
important before the job application process.
yeah, do research, create a few projects, and document them because even if people are not looking at them in that process, it's something that whenever a topic comes up, maybe let's say you don't know a specific tool, right? But you have now okay, it's in this area, it does this. I have done a project in my portfolio that is literally doing the same thing. It's just a different tool. Then you can say, I didn't use this or I haven't used this before, but I used a different tool in that project that I did, and that was that kind of a pipeline, and that were the things I'm working with. These were the problems that I had, and you can theoretically back it up with after the interview. Somebody goes to your GitHub and looks at the project. Okay, there it is. There it is. Right.
Hmm. I love
And I
that.
think
No. Mhm.
that's very powerful, even if maybe it's not in the first phase very much used.
Hmm. And Justin's asking about the interview process. I think the interview process might be not only different from like company to company and even to country, but like, is there a specific maybe core things that every interview involves in data engineering?
Difficult, as you said, it's always different from company to company. One thing, and I personally I hate this. I understand why people do this or companies do this, but I think it's a silly thing that they're sending you to coding tests,
Hmm.
Python and SQL tests. I think this is completely stupid. It's a good way of measuring it because it's a standardized test. But it doesn't. First of all, when you are coding and you forget something, what do you do in your normal day of work? Either you use Google or you use ChatGPT nowadays, right? Give me a quick hint. Okay, I don't know. I remember. Okay, so that's why I don't like the coding tests. But also, if you first start with the standardized coding test, you you can't assess these capabilities of a person that I said earlier. Like, how can you talk with people? Can you bring the requirements into your process and understand what to do? And these kind of communication skills, this kind of abstraction. I think abstraction is the right word. Skills to figure out what to do, that is not tested. And if you first test the coding thing, okay, but that's something that comes up very often, these coding tests. So
Hmm. By coding
as
test, you mean
engineers,
like you mean DSA, or what do you mean by coding test?
that they send you coding tests or send you to a platform where there are these
Automated, like.
all,
Hmm. Got it. Okay,
unfortunately.
and Emily asked about your blueprint. I do have an answer to this, but what do you think? Does this blueprint look
No,
good?
no, no.
Oh
You can do this fully there, because where is the ML going to be? The ML is going to be in the processing part, and it's going to use the storage part. And when you look at, let me, I have a slide here. Where is that? One sec. Here, because when you look at the typical machine learning process, right? the typical machine learning process, you have the training, where you train your algorithm, and then you have the production phase where you deploy it to, and then the data comes in and gets analyzed, right? So, as from a data engineer perspective, what does the scientist need? Good data, right? You need to have the inputs for the training, which is usually some kind of very often some kinds of files that lay in a data lake somewhere, because you need a lot of data to process this. So thinking about the blueprint, what do you have? The data is coming out of the storage area. It's coming out of something like a data lake. The actual training you do in the processing phase, processing stage, and then the outputs your model will be stored most likely again in the data lake as your model file. And then you bring this into production, and this is where you usually then you're not working with that large amount of data, because you want to have quick results, right? Maybe the data is coming in as a streaming or as a stream through a streaming part of the platform. People are doing something in a credit card environment. Credit card transactions are made, and you build an algorithm for fraud detection. Then you deploy this, and whenever a transaction flows through the process, that algorithm looks at that transaction, evaluates it, and creates the output of it's okay, it's not okay. Right? And still that whole process that fits into the blueprint.
Great. Again, yeah, I think this is also a great segue to. I know you prepared some interesting roadmaps from every single role, and but this one is not an engineering role. What do you think about this?
Technical writing. So the thing is, as I said earlier, you need to have a knowledge in Python and in working with relational databases. So that early step for you, that is going to take some time for you. That is always difficult. That is also where people very often get annoyed by it, and they drop it, because it's literally a steep learning curve at the beginning. And you need to understand, okay, this is something that I'm interested in, and I'm going to go on that journey, and then that journey might take a year instead of 6 months.
Or
But
2 years?
it always depends on how much time you can invest. If you have the time and you can invest, you can and you find out that coding is actually something that is, because it's literally, once you understand it, it's easy to code, because it's literally a process. It's always the same thing. Once you understand the building blocks, you can build a code. It's not super difficult, but you need time to learn it, and you need to invest time. As long as you can do that, you can. But these basics you need, and then you can decide, okay, what do I want? Am I interested in something like AWS? Are people searching for this? Then move there, get hands-on experience. That is super important, and then it's time to apply.
Love it. Great. I think that, what do you think about, I'm curious as well, data engineering skills might differ depending on the domain. For finance, like hedge funds or private equity, skills are needed. And
The thing is, so I don't think these skills are super different, because the tools that you're using, or the pipelines that you're building, are very familiar, or very similar is the right word, very similar. The difference is the domain. So you need to, and that is something that I think is important for a good engineer. Maybe not in the beginning when you start, but you need to as quickly as possible need to understand the domain. Without understanding the domain, you can't really understand the data that is coming in. You can't really understand what are people going to do with that data. which part of the data is important or might be important later.
Mm.
So I think for in that case, I don't think fintech or hedge funds or that is all financial stuff. I think the domain is the important part here, the important
Mm.
differentiator.
I guess the question is also, I'm curious, especially on the blueprint that you showed, there's some parts within that, depending on the domain, might be more important, and depending on the role. For instance, if it's hedge fund, that means they care a lot more about latency and to get more real-time data so that they can make predictions much faster than everybody else. So I guess things like this would matter
Yeah,
depending on the domain. Yeah.
yeah. I think, of course, then you would go more towards maybe towards streaming, more towards getting quick results, right? On the other side, if it's something long term where you look at long term trends, then you use different tools. But again, this comes down to understanding which tools are there, what are the tools good at, in what category do these tools fall, and then as a good engineer, if you're starting in the green field, you need to understand, okay, or try to figure out what do I need, where do
Mm.
I need to go, maybe do some benchmarking. That's how I started with Hadoop back in the day,
Mm.
setting up a cluster, understanding what's the upside of it, where are the limits, does this work for us, and then you make the decision. How does that fit? Right?
Mm. So by benchmarking, you mean just understanding different options and
Or if you're working at the company and your goal is to set up this platform, actually building this up
mm.
and sending synthetic data through to
Mm.
actually see does that hold up? Because like with benchmarks, I I know a lot of people look at benchmarks and there are always these tool vendors. They always have the awesome benchmarks that show how much they are better than everybody else. But very often you need to look for it, look at it for yourself, because your data might be different than other people's data, and your use case might be a bit different. So
Mm.
that is important.
Great. I think this is a great segue since you mentioned a little bit about synthetic data. We can talk about either you choose either Gen AI, or we can talk about roadmaps because people are trying to get.
Um, I mean, I don't care. We can go into both.
At
Where
the
do we
same
want to go?
time.
Let's. I think the next thing on my slide here is something with Gen AI. And this is something because retrieval augmented generation. This is something that a lot of companies do and need, because they don't want to. First of all, they don't want to send their data to OpenAI, right? You don't want to send your company data somewhere. And also, you have your documents in the company that you actually want to search, that you want to work with. And this image is from Elasticsearch, from the Elastic website, because I used this to build a project that is coming out in the academy I think in February. And that is a RAG project that actually uses Elasticsearch as the store for your index data.
Mm.
Now, when you look at this process, and I have an example later about this. When you look at this process, what is happening here? You on the top here. So for everybody who's watching, who's on the podcast, the top is the data, is the part where you get the data in. On the left side, you have your file. Here we see a JSON object, basically a document, and through here with Llama index pipeline, that actually then writes the data that looks this indexing of the data and puts the chunks into Elasticsearch as the vector store. So this way, you take your data that is laying around in the company, your files, drop them in, and then these will get indexed in Elasticsearch. And then on the bottom, you have your way of querying the data, right? You have the user that is sitting in front of the UI, making a query to the Llama index query engine, and that retrieves the data from Elasticsearch, puts it to a GenAI model, for instance, Mistral, the query and the results from Elasticsearch, and that LLM then basically polishes the output and makes it, maybe adds a bit of information, basically makes it nice, polishes it, and then delivers the response to the user. Now, I already took it away here. I made red circles around the important parts. The whole GenAI thing isn't really a big thing here. This is like the LLM model. You don't need to develop this. There are a ton of models out there that you can use. In this kind of use case, the important part is, okay, I have my files. How can I actually bring the information from the files into a form that I can then store into? I'm pointing in the wrong direction here. It's because it's weird. That you can bring into the Elastic store, right? So that first part is very important. You need to figure out how does the data look. You need to do tests. You need to extract the data from the files. You need to extract metadata from the files that you then can basically salt your data with, and then put this into Elasticsearch so that you later can actually retrieve the right information. And that is a huge problem and a huge thing that you need to build as an engineer, right? So how Llama Index works is not really important for you as an engineer. It's good to understand, but the thing is, how can I actually prepare my data to make it usable? And the bottom as well, that you then have when you query the data, that you have a system that actually then can query the data from Elasticsearch, combine this with the query response, sends this to the LLM and gets the information back, and that sends it and or presents it to the user. Like, for instance, you could do this through an API that you built. That is the easier part of both. The very difficult part is the top part, on how to get the data in.
Indexing part.
And yeah, the indexing part. The not especially the indexing part itself, but actually preparing the data so it can actually get indexed, and that no data is missing, that no data is wrong, and so on. And what I built with this, I built basically. I'm always saying we. I have people that help me. I did the first basic project, and then my guys helped me make this better. We take CVs and then index the CVs, and so that you can actually speak with the CVs and you can ask questions about the CVs, and you will understand. Once you know the data and once you understand what is it that I'm working with, it's not that easy. That is a lot of work to actually preparing the data. So that is one part, right? We need to work on that. And then when you look at the bigger picture, right, this needs to run on somewhere. Somewhere we need to build this whole thing. And I took this example here out of a YouTube video where I actually made a reaction video to it. From time to time, I like to look at these. AWS has on their YouTube channel a playlist that is called My Architecture, where people actually show the architecture that they built in their company. And the problem is always they leave out a lot of interesting stuff that they don't want to talk about. So you need to think of, okay, what do they maybe leave out here and not want to talk about? But like in this case, this is the exact same use case. We have the data is coming in and it's getting on the top here, it's getting put into S3, which is a file store. From there, Lambda is actually processing the data. It's cleaning the data, it's indexing the data, then putting it into OpenSearch, which is basically Elasticsearch. And then on the bottom, you have your API, where clients make requests to. That API uses a Lambda function in the background to actually do the logic. And that communicates again with your OpenSearch, gets the data out of your store, and talks with Bedrock, that is the LLM, to then clean the data and sends it back to the API gateway to give it to the client. right?
Mm.
And now you can see, okay, we also have DynamoDB here for storing the history of the chat. This is basically for something like ChatGPT. But then you can look, okay, S3, where does this fit? That fits into storage. Lambda is a processing tool. Dynamo and OpenSearch, these are also storage. These are storage systems. Bedrock is an LLM. Again, Lambda processing, API gateway, that would fit into the connect phase. And then you see, okay. Now I don't want to use API gateway. I want to use something different, fast API or whatever. And then it's the same thing.
Mm. I did not know that they do that. What's the AWS cloud projects? What's the name? I should.
If you search on Google, if you search on YouTube, AWS My Architecture, you will get to the playlist where they do this, and they do this for a long time now, for years. They have a big
Oh
a big
wow, almost a million,
list.
800,000 followers. Yeah. And
Yeah, but it's the videos themselves. Sometimes they don't have that much views, which is sad. But I think for us it's good for us engineers, so that we understand what are people doing, right? What are companies doing? Because we see all these tools, we see all the things that we hear all the things on the internet, but there actually companies come in and show this is our problem. This is the kind of data that we use. Usually they are not that open about the data, and then they show you the process that they're doing, and it's a cool thing.
that's really cool. Thanks for sharing. I think we have a follow-up question on that actually. What is the most challenging aspect of data engineering for LLM and RAG applications? How do you suggest we handle such problems?
So again, I haven't done this in a real life environment. I've looked at this from a conceptual view, from understanding what are people doing, from understanding what tools are there, and from looking at, okay, what could be a use case and how can I actually resolve that use case with it. And again, the most important or the most difficult part is always the part for everybody on the podcast, we still have that image up where you see on the top S3 goes into Lambda, that goes into OpenSearch. And that part is always the difficult part. Maybe not just from a actual processing standpoint of making the logic, but let's say now we have your Lambda. Now, suddenly you have a process where people bombarding S3. There are tons of documents coming in. It's your company is working great. Now you have 100x of files coming in. Now you need to scale your infrastructure. How do you do this? Lambda doesn't work anymore. You need to do something containerized. You need to manage the containerized environment. This is something that where the fun then comes in, where it gets difficult, and where actually the cool things start. But that upper part is the important part. That's the difficult part.
Did they talk about scaling, how they scale their architectures at all?
No, but in a different project they did this. It was very interesting. They had ECS running where they are basically spawning containers, and the files were not going directly from S3 into these containers, but basically they used the message queue in between as a buffer. That's why I put these into the buffer category as a buffer, so that if your processing is behind, nothing gets lost, and also you can basically figure out is there a buildup in my message queue? Do I need to scale my processing because the message queue is growing, and that kind of stuff. So yeah.
Nice. Yeah, guys, you have to check out Andreas's. I did not know that you do these like review videos. I would love to watch them. But yes, guys, follow if you don't already Andreas's YouTube channel. Great. What else would you want to cover before we open up for Q&A?
You said a few examples for roadmaps,
Oh, yes, yes.
but we need to go through
You
them
need to-
quickly, because otherwise, like I just I just did a 1 hour live stream this week just on the roadmap for data analysts. So this can go out of hand.
Oh, I see. Well, I guess we
But
can also ask people who, what current roles are you guys in? Are you software engineers,
true.
analysts? Because Andreas prepared for many roles.
I have a few roles here. I had the analyst here, the data scientist, and I have the junior data engineer, basically how to get better.
What
These
about,
two I have here.
well, should we start
So
with junior data engineer for now?
we can, we can,
Since it's,
we can.
yeah.
Um, Basically, one thing that you have to think of as a junior data engineer. So you might have some knowledge in that, right? But very often as a junior, you don't overlook the whole platform. You don't overlook the whole pipeline or understand the whole pipeline. You most likely focus on smaller parts, which are your responsibility, but you don't see the big picture. You're not working, or you're not in the process of the architecture, in the process of selecting tools. So as a junior, I always say, okay, learn the basics of platform and pipeline design. What tools are there? What are the different pipelines that you usually build? Stream processing, batch processing. Which type of data stores are there? What are they used for? How's the data usually modeled in them? I think that is something that is very important. Then I always say, like, fresh up on, if you feel like this is important or you don't have that much experience, just fresh up on Python and SQL for data engineers. I think that is important. And then make a decision, because as we said, you very often have the transactional part and you have the analytical part. Make a decision. What do I already know? Do I already know dimensional modeling? Then you don't need to do this. But then most likely on the relational part, you're a bit weak. So look into this. Try to figure out, do I need to maybe learn a bit more relational modeling? Do I need to practice a bit more dimensional data modeling? I think that is something an engineer or junior engineer should do to get better. And then start build pipelines, build ETL pipelines on AWS, for instance. Work in Dockerized environments. Right? You might have a fundamental understanding of AWS, but then take it to the next level. Don't just use Lambda. Build a processing where you use containers, where you use the container registry, where you use ECS,
Oh,
where
Andreas,
you.
question. Yeah, before
Yep.
you move into the next steps in the roadmap, what is dimensional data
Okay.
model? Yeah.
So the idea is, usually when you have a relational data model, that means, let's say, that means you have entities in this model, and these are all connected via relationships. So you might have a one-to-one relationship, you might have a one-to-many relationship, and there you build your whole data model through that. It's very complicated, but the cool thing is, it's because it's so relational, it's very well defined. So very often when you start learning this, you're starting with a bookstore, where you build a bookstore and you have your books, you have your people that are actually ticking the books, and you have the different categories and so on. And then you have the dimensional modeling, and that is more built, more loosely built. You have a fact table basically in the middle, and then you have dimensional tables around this. Very often people build a star schema, where you have that one table, and from that table everything goes basically, or is connected with it. So it's more loose, a more loose model. It's easier to create. You don't have these strict relationships. Therefore, it's better for analytics, because it's a lot free. In the early stages, very often you even start with these one large table models, where you say, okay, I'm having and people call this the medallion architecture, the bronze, silver, and gold layer, where in the bronze layer you have your raw data, where nothing, it's just the input data. Then silver, it's cleaned, and then in gold is where you build your dimensional model, where you build your fact and dimensional tables, and actually where the analysts, for instance, then work with the gold tables with the dimensional, and that's the difference. I started with relational data modeling. I was never a big dimensional guy, because the use cases that I have worked with were always transactional use cases. I wasn't really big into analytics use cases, so I had to learn this myself as well. But yeah, that's the difference. And then let's quickly go back to that roadmap. So once you've built this, then you would look into, okay, how can I bring in continuous integration, continuous deployment features here with GitHub, with AWS, through Docker, right? Then you have your pipeline, you have your ETL pipelines, and then look into, okay, Lakehouse. Lakehouse is something that is very strong right now. People use that on Databricks, on other, like also with Snowflake and so on. So where you store your data into the data lake, you just drop in the files, and you have a system that can actually query the data straight out of the files, and you can work with the files. Of course, you need to have then a data catalog so that the system can actually understand what are these files, what's in these files. And this kind of things, then automate or orchestrate this with Airflow at the end. Maybe build a streaming pipeline, because you never worked with streaming. So that's a way how to become better as a junior engineer.
I think I jumped a little ahead of myself, because people are asking, what is the data science roadmap, or what is the data engineering roadmap for beginners? I thought this was like this is the junior data engineer roadmap, actually.
Yeah, this is not for complete beginners. This is I haven't built this. This is one for, you're already working as a junior engineer for like a year or something, and you need to get into it. But you're going to see, like, let's just look at the one for the analyst. It's not so super difficult. You get the basics, right? Platform pipeline design, understand the different data stores. As an analyst, you work with the dimensional modeling area, or with analytics, look into relational modeling. You most likely don't do that much in Python. Get into Python for data engineers. Then at some point you need to get the data to you, work with APIs, and then start with, for instance, AWS or Azure, and try to go then from there, go from what you're best at, like Snowflake, transform the data with dbt, right? Because you already most likely know this. This is more of an, again, analytics. You already know how to do dimensional modeling. You already know how to prepare the data for the analyst. So, for instance, something like Snowflake and dbt can be a very strong combination to practice. People use this all the time nowadays. Yeah. These are just examples. Of course, you can order this a bit different. You can switch out the tools a bit. But this is something that I think is a good plan for people to do, because then they have the skills. In this case, you have AWS. You can use AWS for the first part of actually getting the data and getting it into the data lake, and then you have Snowflake actually take the data out of your AWS data lake, and then you transform it with dbt and so on.
Great. Is there another one that I think we had, or is that?
Somebody said, would love to see the data science roadmap. Okay, let's go to the other one. Yeah, but that I basically put APIs for a lot here first for the data science roadmap, because you most likely are going to work a lot with external data. You're going to work a lot with APIs, getting data from APIs, processing it. So I think that is something important. And then as a scientist, you most likely have already written code in Python. Maybe you're just transitioning from R to Python, or you need to do that. But then you should get into Docker, so that you can actually Dockerize your code. You can run your code anywhere you like, make it available in the distributed processing environment, and then have some relational data modeling, and then build something. Build something on AWS where you say, okay, I have my data. I'm using a Dockerized algorithm where I run this as a Docker container, and then at the end, I'm putting the data into a relational database, and then have people looking through it, or use an API, create an API where you can request the data then from it, right? And this kind of things, then maybe again go with the lakehouse thing, and then if you want, then add on top of the of it again, learn the dimensional data modeling, and get towards the other area, get towards the data analyst, and put your results somewhere.
Hmm. Yeah. And what about working with other stakeholders? You just mentioned you would work a lot with analysts, work with software engineers. Who do you think is the
It's also project managers very often,
Mm.
right? In a corporation environment or corporate environment where there are initiatives where there's somebody sitting in front of the project or in front of the product that is actually using your data, you need to talk with these people.
Mm.
Sometimes it's actually infrastructure, because maybe you're not handling all the infrastructure. Maybe your company does not want to. We were talking about financial stuff. Maybe they don't want to go on the cloud, or they have data that can't go on the cloud. You need to have it in a data center. Then you need to talk with the data center people so they can actually give you access to the servers or give you access to that database and that. So these are people you very often talk with. You the whole data protection, or security is the wrong thing. Security is a part, but also data protection. In Europe, we have the GDPR. I actually don't know now from the top of my head what this is an abbreviation for. General data protection something. It's not arrangement, but I think you get the point. You need to maybe work towards, or often work towards that you document your work, that you do the risk assessments, that you document who is responsible for what, and so on. So these are things you actually, and then you have to work with the auditor, that you then explain it to.
Oh, I love that. You should make a separate video about that stakeholders, unless you already have it. But
Um, that's actually a good point. I'm going to write this down more towards stakeholder, and examples for stakeholders.
yeah, people want to know the dynamics once they're at the job. But
Yeah,
everyone, we are opening up for a Q&A session. I guess, Andres, is that all that you wanted to share for now?
I think so. Yeah, yeah.
Okay.
We have something at the end for you, some bonus,
Yes.
but
Sure.
that's just.
You can share
Let's
it
see.
now or
We can
whatever.
share now. Okay. Let me see.
Is it?
Because, like, as I said, I do two things in the academy, in Learn Data Engineering, or at Learn Data Engineering. I have the academy where you can come in, it's completely self-paced, over 30 courses and projects, over 500 lessons, and 55 hours of content, I think now. And I'm also doing once a month a session for people, an office hour where people can come in, and we have our Discord there, and I do coaching for people, like together with my coaches, personal coaching for 6 months, where you can every week come. And for everybody who's here, and for basically Mary's people, I set up a discount. So if you want to come in and if you want to try this out, I use the discount break into data on the academy page. That works for the 12 months access. That works for the unlimited access. Go to the checkout, and at the checkout use break into data,
Love
and
it.
then you get 20% discount.
Thank you so much for sharing, guys. Check out the academy because, as you said, I don't think there's anybody else who's taught that many people in data engineering or in data space, actually. So, I really love when veterans like yourself come in and share all the industry insights. Even today, we learned so much. So I'm excited.
Yeah,
Use the
maybe.
code break into data if you're interested. And yeah, let's open up for a few more questions before we wrap up the recording. Um, so I think we had some people asking questions.
The first one from Justin, yeah, that one is a good one. Um, it has it has to do with governance and AI and vector databases, but I think that hits on a good point. Governance, that is something that is very important, not just for Gen AI use cases, where this is actually a bit of a difficult use case for these kind of vector databases, to make sure that people can access the right data and it's not open for everyone. Where I recently read that a company had they set up their own system, and then it was basically every employee could query data that was in their CTO's email. Like from the CTO's email,
Oh,
these were also indexed, and people were able, like everybody
wow.
was able.
Wow. Was
they,
that a big
so
company? I could imagine.
I don't remember. I don't think so. But I don't remember. I don't fully remember. I think I read this on X, or on LinkedIn. I don't remember. But I found this very funny, and I can see that because governance is something that is very important, right? Understanding where does the data come from, who is responsible for that data, how does that data look, where is that data going, who's responsible for the destination, who can access which data in there, what data needs to be masked, what data needs to be completely cut off, what are the user groups, and so on. So I think the whole governance topic, that is a very important topic that's also often overlooked. So generally, this is an important thing, and companies need to figure out a good solution for this.
I love this. I think there's a new term called data contracts or something like that. Is that relevant?
I know there's especially one guy on LinkedIn that's always talking about data contracts. I don't know. I'm not sure.
Okay, we don't have to talk about this.
No, it's
Yeah.
I think the general thing is people often think it's their thing is a good idea and it's the best thing ever and everybody is going to adopt it. But very often the adoption rate is very low and people are very slow, and they would be happy with even a simple solution, even a solution that is a few years old. It would be better than nothing, because literally sometimes there is nothing.
Mm,
So yeah.
I see. It's all about short-term problem solving, I guess.
Sometimes.
Got it. What? Let me know if there are any questions that you want to pick. Guys, put it in the chat. Time to ask all your questions. Let's have another few minutes, 5 more minutes, and
There's somebody said GDPR, General Data Protection Regulation. Of course, R, not A. I don't know. So, with other teams, Apache Iceberg is something that everybody talks about right now, because it basically brings the transactional part to a data lake.
mm,
That is something that was never possible. Let's see how this goes. I still feel like you always have to think about the Gartner hype cycle. Right? The Gartner hype cycle is where you have that steep hill in the beginning. It goes steep up, and then you have that top, and then it falls falls down a cliff and goes into a hole basically, and from there it slowly comes up into I think it's called plateau of productivity. And I feel like the whole Apache Iceberg thing, that is still, I haven't checked I think they made another hype cycle. but I need to check it. But I think it's still very early. So let's see how people actually use this and how this gets adopted.
Hmm.
It's an interesting topic though. Uh, somebody, the top one. Can you bring in the top one?
You mean the last one? This one?
Yeah,
Or
this one here. Uh, it's should I read it?
yeah, yeah.
Yeah. It says, I noticed that you use AWS for most of your illustrations. Any reasons why you prefer AWS to other cloud platforms like Azure and GCP? I'm an AWS guy. I don't know why. I feel like AWS is more natural for me to use. It's easier for me. It has a very great set of tools there. It was the first one I started with. Well, that's actually not true. I was starting with Azure, and I felt like this is terrible, so I went to AWS. But like it's just my preference. But it's basically anyone is good. It doesn't really matter. Doesn't really
I
matter.
guess AWS is just has the largest market share, and many people, yeah, most companies use it. So, but
By
I think,
far.
yeah, Azure. That's what I heard. Azure is more common in Europe.
Yeah.
But
But in terms of services and so on, it's largely the same. Of course, AWS has a few things that others don't have, and I feel like, for instance, with Azure, whenever you set something up, it takes forever to set it up. With AWS, you just click and it's there. I don't know how they do it, but like that's something that is super annoying with Azure. But yeah.
are there any metrics used for these type of projects? Maybe performance, functionality. I guess for data engineering pipelines, are there metrics that stakeholders or project managers set, or how does it work?
Well, these very well. You always have different metrics. You have the metrics from a project manager side, or from like an external guy who needs to use your data, needs to use your platform. They have their own metrics, right? They want the data that fast. They want to have that amount of data at a time. People, how many 10, 20, 100 people are querying data from this at the same time. And they have their metrics, but from an engineering perspective, the metrics very often are like how fast am I processing the data? Right? Do I have a large delay between incoming data and actually processed data? You will have your metrics. What is acceptable? What is not acceptable? You will look at error rates, which is very important. Yeah, but these are more functional things for the data pipeline that are important. And so it always depends on who you're asking. But you, as an engineer, you need to be aware of what these other people need, right? What your data scientist needs to actually process the data. What kind of data they need to be filtered out. What maybe you need to do the normalization for them, so that they don't need to do this on their platform or in their processing.
Great. Should we
Yeah.
put last question? I know it's not about data engineering, but we have Malik over here who wants to know, how did you build your brand? Many people want to build their own personal brand, and I think you have more than 300,000 followers, if I'm not mistaken, on
Uh,
all
on
or
on all, yeah, but you know how it is. People move. There's a large overlap, I think. Yeah, on YouTube I have 200,000 something, and on LinkedIn 100. But like my idea when I started with this, my idea was never to go and brand myself as the big data
Mhm.
engineering guy, and I'm the greatest and so on. My thing was always, and that stems back to I once was in an interview where the guy we interviewed came in, and we were talking, and he said, "Okay, if I because is that I need to keep in mind when I go from my company where I have a standing right now, where people know me. When I go to your company, basically nobody knows me, and I have zero standing, and I start from zero basically. And that made me think like, what happens if I need to do this? So
Mm.
that's where I decide, okay, I'm going to just start posting, just going to show what I can do, and not just for myself, but also to teach people, to show people how stuff works, and through that, softly get into the thing of positioning yourself as somebody who's capable, who's a good engineer, and that was basically my goal back in the day.
Mm.
And there was no academy or coaching or even doing this full time. It was just for, okay, let's see what the future brings. I want to position myself as an expert, as somebody who can do stuff. And I recommend this to everybody. If you have your field, I know you have a broad audience. If you're a data analyst, if you're a data scientist, fill your profile with interesting stuff. Fill your profile with your opinions, with your experience. It does not matter. You don't need 100,000 people that follow you. You don't need 10. You don't need 5. Your goal needs to be important. Okay, what is your goal? If your goal is that the next time you want to switch jobs and you want to have people look at your LinkedIn profile, you want them to see what you're capable of. You want to have make a good first impression through LinkedIn, because that is what people do. Whenever I do a talk with somebody, whenever I have a meeting with somebody, the first thing I do, go to
Check the
LinkedIn, look at
LinkedIn.
their LinkedIn profile.
Mm.
And that is super important. Fill that profile for yourself, but also for other people that might want to come in. They find you somewhere and they want to see, who is that? Who is that
Mm.
person capable? What is that person capable of?
Mm.
You don't need to become an influencer. That is 99.9% of people don't need to do this.
At the same time, you need to be active on social media, especially on professional social media, I feel like, because there are so many opportunities there. People are posting about their own problems and if they're hiring or not. And I hear people also say that, hey, I hired someone from my comment section just because he or she's been supporting me all this time and they know what they're talking about. I think it's a great way to like connect outside of interview or just like meet new people.
Yeah, that's true. That's true. I think LinkedIn is the best platform for this. I also like X, but the problem with X is I feel like X is full of politics. Like
Mm.
you always see these politics posts, and it's like, oh, it's boring. I don't want to see this. I wanna get into conversation with someone. I want to talk about technical stuff, and I feel like more of that is happening on LinkedIn.
Mm.
And so for me, LinkedIn is the platform. LinkedIn and YouTube, well, but LinkedIn is more of a one-way street. You can write comments, but it's not like everybody can post their own stuff.
Mm.
But yeah, um,
Yeah.
I think it's very important. LinkedIn is the thing.
Great. Great. I think that time is up. We had a great session, everyone. Thank you so much, Andreas, for coming in and sharing your
Thank you.
knowledge. We learned a lot. I hope you guys did too. Share in the comments how was the session for you, because we'll try to bring in guests like Andreas every week. And yeah, I would love to hear your feedback. And after this session, we will send the slides, I guess. Andreas, you're going to share your slides and
Yep,
everything
I'm going
else,
to
the
send them to you. Yeah.
code and everything. Yeah. Yeah, that was great. Thank you, Andreas, for coming in, and enjoy your evening.
Yeah, thanks, Mary, for inviting me. I have to say, I really love that you're doing this, that you bring on people, that you have that community. I'm a silent visitor on your Discord, and for some time now. So I really like that you foster this community, that you bring people in to talk about this, and I'm happy that that I was able to be here and talk with you and share some interesting stuff with everybody who's here. And yeah,
Oh, thank you so much. Always feels nice because we've been doing it for a year only, and it was we've been wanting to have you for like half a year, so we finally made it.
yeah, I know we had some problems at the end of last year with the scheduling.
Yes, no, but hoping to
That
see
was
you
largely
again.
my
Yeah,
fault,
no
but
worries. But
it's
we'll hoping to come back and probably see you again. So we'll keep this in
yeah.
mind, and wishing you all the best with your new cohort and everyone who has a chance and wants to learn more about data engineering. Check it out. We have
Yeah.
lots of great reviews and testimonials, even from our community, about Learn Data Engineering platform and about Andreas' work. And in fact, the David that I mentioned, I think he got a job thanks to you as well. And
Mm.
yeah, so awesome. Great
Yeah.
session.
Okay. Thank you, everybody. Have an awesome day wherever you are. Tomorrow is already Friday, so the weekend is for training. The weekend is use that for a bit of
Yes,
work
for
for
building.
yourself.
Oh,
And
okay,
then
and
yeah,
that too. All right.
thanks.